Very good morning, students. Today we can continue the topic of physics, that is the force. Okay. Now this topic is particularly of 11th class and used for CET purpose. Okay, means for the CET point of view, you can see that to that angle we can learn that force. Meanwhile, for the that means your NEET examination, Newton's laws of motions, this topic is there. From that some part has been taken here in that force of 11th class. Okay, so you can continue the force. Particularly before learning the force, you have learned the Newton's 3 laws of motion in your 8th-9th class. Okay, so what are the Newton's laws of motion? We can define that laws first of all. We can state that laws and then we can go actually the definition of force. Okay, so the first point, sir, what is exactly Newton's first laws of motion? Okay, you see here Newton's laws of motion. In that force we want to learn, and now the first law is Newton's first law of motion. What the Newton's first law of motion? What it states? What the Newton has given in his first law? According to the Newton's first law, every body continue in its state of rest or uniform motion unless and until some unbalanced force acts on it. Okay, means a body will continue in the same state of rest or uniform motion unless and until you are not applying some unbalanced force on it. Okay, means if you are applying some unbalanced force, then what is going to happen? Then the body will, that means, change its state of rest or that uniform motion. So what is the law is telling? Body will remains in the state of rest or uniform motion unless and until somebody will act unbalanced force on it. So that is the Newton's first law of motion. Okay, so that is very simple. If suppose any duster is lying on the table, then unless and until I will not apply any external force, unbalanced force, the duster will be remains in the same state of motion. So that is the Newton's first law of motion. So if this is the Newton's first law of motion, then question is, what is Newton's second law of motion? Okay, what is Newton's second law of motion? In Newton's second law of motion, particularly Newton has come to the conclusion of the definition of force. And according to that second law, the rate of change of momentum is directly proportional to applied force, and it is always directed in the direction of force. Applied force is always in the direction of force. Okay, or momentum takes place in the direction of force. Okay, so now what is that second law is telling? Rate of change of momentum means dp by dt is directly proportional to the applied force. Okay, and it takes place in the direction of force, means F is directly proportional to dp by dt. So that is the Newton's second law of motion. And in Newton's third law of motion states that every action there is equal and opposite reaction. Every action there is equal and opposite reaction. If I will just hit to that board, then the board will also hit to me. Okay, so therefore every action there is a reaction is there. That is the Newton's third law of motion. We are able to walk because of Newton's third law of motion. Because when I applying the action force on the ground, then due to the reaction force of the ground exerted on my leg, I will be able to move in the forward direction. So that is the your Newton's third law of motion. Once you got idea about the Newton's third law of motion, then we are coming to the point, sir, what is exactly inertia of a body? Okay, now inertia is the natural tendency of a body to remain in the state of rest or uniform motion. So that state, natural state of the body is called as inertia. Okay, there are 3 types of inertia actually. Inertia of rest means body will always remains in the same state of rest. Okay, natural tendency to remains in the same state of rest. Inertia of motion, once the body is in motion, body is expecting that that body should be always remains in the same state of motion. That is called as inertia of motion. Inertia of direction. Okay, if the body is moving in a one particular direction, then no any body will be trying to change its original direction. It will be remains continue in the same direction. So these are the three types of, that means inertia of rest, inertia of motion, inertia of direction. Okay, so that is all about the inertia. Then we are coming to the point, sir, what is exactly force? Okay, what is the force? Then from the Newton's second law of motion, that rate of change of momentum is directly proportional to applied force, and it is always directed, or it takes place in the direction of force. And from that we have come to the conclusion of what is the force. But sir, first of all, define F is equal to m into a. So that formula we are coming to the conclusion from the Newton's second law of motion. But sir, how will define it first? Force. Okay. So the force is that physical quantity which can changes the state of rest or the uniform motion of a body along the same straight line. Okay. What is the force? Force is that physical quantity which can changes the state of rest or uniform motion of a body along the same straight line. So that is called as the force. Okay. And so therefore that formula for the force, we can come to the conclusion is F is equal to d dt of change in momentum, mv minus mu. And if I will take m out, then d dt of v minus u. Okay, and so therefore m into v minus u upon t will be a. So therefore rate of change of that velocity with respect to time is acceleration into m, that is equal to force. So therefore force is equal to mass into acceleration. So then what are the units and dimensions of the force? So it is measures in the unit, SI unit of force is kg meter per second square, or we can also say that in CGS system gram centimeter per second. And as this is given by the Newton, so therefore it is also denoted by capital N or small Newton, N-E-W-T-O-N, Newton. Okay, or that means your dyne. In CGS system it is also measures in dyne. Okay, gram per centimeter square or dyne. So there is a relation 1 Newton is equal to 10 raised to 5 dyne. So what are the dimensions of force? The dimensions of force is m1 L1 t raised to minus 2, because mass into acceleration. So these are the direction of, that means your force. So whether the force is scalar or vector, so this is the vector quantity, which this quantity is this, that is the vector quantity. Then now question arises, sir, what are the effects of force applied on the body? Which are the different effects of force acts on the body? So there are particularly some effects are there on that force. So which are that different effects? First of all, due to force or the applied force can change the speed of the body, If suppose the body is in motion, then as soon as you will apply the brakes, the body comes into that rest position, means you have decreased the speed of the body. Or if you are pendaling to the cycle, you are increasing the speed of the body, means because of applying force on that bicycle, you can accelerate that bicycle. Or if you are applying when the body is in motion, and if you are applying the force, the body comes into the rest also, means applied force can changes the speed of the body, speed can get change, speed can change because of force. Second, it can changes the direction of the body, speed can change the direction can be changed. Okay, our direction can change because of that force. So how the direction can be changed? If suppose body is moving along the circumference of circle, means that we can say that this is the uniform motion. then due to the applied force, the body will continuously changing its direction. Okay, every point the body will change its direction due to that applied force on the body. Third, body can change both these things, that is speed as well as direction. Speed as well as direction can change the force. Okay. So for example, the projectile motion is the best example of that, means your speed and direction, how it can be get changed. When the body has been thrown vertically upward direction, the speed will goes on decreasing. At one particular point it becomes 0, and again the body comes in the downward direction, then the speed will be goes on increasing. Okay, so therefore that is decrease in speed and that will be increase in speed. Okay, so that means speed can be changed, as well as the direction will also change. When body goes in the upward direction, then after that it will falls in the downward direction. Speed and direction can be changed in that projectile motion. So the next point, one more important effect is speed can changes the shape of the body. Shape can be changed. Shape can be changed. Shape can change that because of applied force, or the effect of force is the speed can get changed, direction can change, speed and direction can change, shape can change. Okay. So due to applied force, so these are the shape of the body can be changed. Means what, sir, exactly? Suppose if you are taking a rubber ball, and as soon as I will apply the force on the rubber ball, then what is going to happen? There, the shape of the rubber ball is going to get, that means change. Okay, and as soon as you are removing that force, the body will regain into its original position. Means because of that applied force, that particular point, that particular instant, you can change the shape of the body. Okay, so these are the 4 effects are there of that force. Once you got the idea about the force, then question is, sir, which are the different types of force? So there are basically 2 types of force. One is a real force and one is a pseudo force. Okay, sir, what is exactly that means force is? So I will say that force can be classified into 2 types basically. One is a real force, okay, real force, and another is a pseudo force, that is the pseudo force. Okay, so what is the real and what is the pseudo force? Okay, pseudo force. Then first of all, for the real force, in case of real force, we can say force which produces due to interaction between the object. Okay, the force which can be produces due to the interaction between the 2 objects. For example, if you can consider Earth and the Moon. Okay, Moon can revolve around the Earth. Moon can revolve around the Earth is the best example of real force. But why this thing happens? Because of gravitational force. Here, the centripetal force is required for the motion of Moon around the Earth, which has been provided by the gravitational force. All the planets which are revolving around the Earth is also, all the planets which are revolving around the Sun is also the best example of real force. Here also the gravitational force, means centripetal force, is balanced by the gravitational force. Okay, so these all are the real forces. Okay, nuclear force is responsible for binding the protons and neutrons inside the nucleus. That is also best example of real force. Means gravitational force, strong nuclear force are the best example of real forces. So what is the pseudo force exactly? Pseudo force is that force which does not have a real origin and does not produces due to the interaction between the object. Okay, so that is, it do not have a real origin and it is not due to the interaction of the object. Okay, that means it does not produces the due to interaction between the object is called as the pseudo force. Pseudo force is also called as the fictitious force. Okay, so that is not the true force. This is the fictitious. Okay, so that is the fictitious force. That is the culprit force. It is not a true force. Okay. So for example, sir, any one example of the pseudo force is the best example centrifugal force. Which is the best example? Centrifugal force. When the body is moving along the circumference of circle, the real force which is acting on the body is the centripetal force. But the pseudo force is acting on the body at the same point is the centrifugal force. Okay, what is going to happen? You know, suppose the earth is revolving around the sun. Okay, or merry-go-round. When that means you are on the merry-go-round, the centripetal force is acting towards the center, but at the same point there is a centrifugal force, and due to that force, body always thrown in away from the center, means in the outward direction. So that force is called as the centrifugal force. Okay, so these are the different types of forces, that real force and the pseudo force. Once you got the idea about that real and pseudo force, then state and explain the different types of real forces. Now you have to learn, so which are the different types of real forces. Basically there are 4 types of real forces. Okay, so which are that? First is a gravitational force, force of gravitation. Second, electrostatic force, okay, or electromagnetic, electrostatics or electromagnetic force. Third is strong nuclear force, and last is the weak nuclear force, Okay, so these are the 4 fundamental forces in the universe. These all are the basically real forces, 4 fundamental forces which we can define in that universe. Sir, what is that first force? That is the gravitational force. Okay, actually, so this force has been given, that gravitational force has been given by the Newton actually. So therefore it is also called as the Newton's law of gravitation. From the Newton's law, universal law of gravitation, we have defined the gravitational force. This force exists between any 2 objects which have the mass. Okay, any particle, any body in the universe can exert this type of force, can appear this, that means there is appearance of this type of force, that is the gravitational force. So now we can come to the point one by one. Sir, what is exactly that gravitational force? What are the characteristics of that force, and from that force what exactly is going to happen? Now see here, what is a gravitational force? What is a gravitational force? Actually, I have already explained that any 2 bodies having some mass, so then there will be a gravitational force. Okay, or particularly due to the gravity, the force exerted by the earth on the body, so that is called as the gravitational force. Earth is one body, and any body which has been thrown in the direction of force or towards the, that means earth, then that time the body will fall, that means towards the earth only, so that is the gravitational force. Particularly Newton, he has given that law when he was sitting under the tree, apple tree, and the apple falls, that time he got that law, and that is called as the Newton's law of gravitation. And so from that laws he has given the gravitational force. What is the Newton's universal law of gravitation? Universal law of gravitation. Particularly you see here this word universal. Why this law is called as the universal law? Because it is applicable for any body which is there in that universe. For that this law is applicable, and from that law we have been defined for one object, and then after that this law has been, that means utilized for the all other objects. So what was the Newton's universal law of gravitation? Newton's universal law of gravitation states that every body in the universe attracts to every other body. Every body in the universe attracts to every other body or any particle with the force which is directly proportional to the product of their masses and inversely proportional to the product of this mass, product of their masses. Okay, F is directly proportional to, sorry, again I will define. Okay, so what is the Newton's law, universal law of gravitation? This law states that every body in the universe attracts to every other body with the force which is directly proportional to the product of their masses and inversely proportional to square of the distance between them. Okay, so that is the correct law of universal law of gravitation. And so from that law we can also say that F is directly proportional to m1 m2 upon r square, or if you can remove that proportionality sign and I will put the gravitational constant g into m1 m2 upon r square. So here that F is the gravitational force, g is the gravitational constant having the value of 6.64 into 10 raised to minus how much? 10 raised to minus 11 Newton per meter square. Okay, so that is the your Newton's law of gravitation, that is the g in that gravitational constant, and m1 m2 these are the masses, r is the distance between the two particles. Okay, so separation of the distance between the two particles. So from that there are some characteristics which we have can define for that Newton's, that means gravitational force characteristics. Okay, so which are the different characteristics are there? So first characteristics, this force is always attractive force. Okay, means there is always attraction is going on between the two particles in the universe. Means when the two bodies which having some mass, so then always they are attracted with each other. So therefore this force is always attractive force. This force is a long range force. This force is long range force. So why it is called as a long range force? Because if I will take, this is the first mass, this is the second mass, if they are separated by some distance r, then at that time, sir, how long this force can be exerted? So this force, first mass is here, second is here, up to infinity, no doubt. As you are going away from that your first mass to second mass, so that as the distance goes on increasing, the force will be goes on decreasing, but up to infinity this force can be exist. But suppose at infinity this force will become 0. Means suppose if I will take 100 is the infinity, then 99.99 up to this point this force can be exist. Okay, so this is the long range force. This is the weakest force in the universe. Weakest force in the universe means here the magnitude of that force you can consider is supposed to be 10 raised to 0. Okay, so that is the 1. So then that force is called as the weak nuclear force. Next characteristics, it obeys the inverse, that means your inverse square law. Okay, inverse square law. So why it is called as the inverse square law? Because it is always inversely proportional to r square. F is inversely proportional to r square. So therefore it obeys the inverse square law. Okay. Then now this is the central force, means these two bodies they will always act. Okay, central force, because the two particles they will be always attracted towards its center. Okay, means if you want to take that distance, so you can take this distance from the center of mass, and one force is always attracted towards this center, another force is always attracted to, another body is always attracted towards the center of mass of the another body. Okay, so therefore it is called as the center force. This force is also called as conservative force, that is also called as conservative force. So what do you mean by conservative force? Then the work done by that force does not depend upon path followed by the body. So therefore it is called as the conservative force. So these are the some characteristics of that your gravitational force. Okay, so these all are the characteristics that we have learned. Okay, again this force does not require the presence of any medium between the two bodies. Okay, so it does not, that means require the presence of any medium. Okay, Okay, so due to the gravitational force, a large number of physical phenomena occurs in the universe. Okay, gravitational force is responsible for the motion of the moon around the earth or planets which are revolving around the sun. So this is the best example of the gravitational force. Means whatever the for that circular motion the centripetal force is required, so that has been provided by the gravitational force in that case for the moon or the planet. When moon is revolving around the earth, okay, planets are revolving around the sun, earth is revolving around the sun. Okay, so this is the best example of gravitational force, or best example of gravitational force. Any body which you are throwing in the upward direction, then it is always attracted towards the earth's surface. So that is also the application of gravitational force. Once you got that gravitational force, the next force which we want to learn is the electrostatic force. Which force we want to learn? That is the electrostatic force. Okay. Actually, electrostatics or electromagnetic also we can say. Electrostatic force or electrostatic force or okay, first of all we can see only electrostatics and then electromagnetic force we can say. Actually what is going to happen, you know, in case of electrostatic force, as the electron is charge, okay, this force is related with the charge, okay, and that we charge, unit charge, okay. So if suppose there are the two charges are there, q1 q2, and if they are separated by some distance r, so then the force exerted by one charge on the another charge, that is the electrostatic force. But here condition is that electrostatic, the charge should be in the rest position. Okay, in electrostatic force these two charges they are in the rest position. Always remember that condition. Okay, so when the Newton has given the law of gravitation in one side in a gravitational force, then the second side the Coulomb he has given the, that is the Coulomb's law of electrostatics. Okay, so that law will explain you the electrostatics force. So what was that Coulomb's law? According to Coulomb, he said the force of attraction or repulsion, the force of attraction or repulsion between any two electric point charges is directly proportional to the product of magnitude of these two charges and inversely proportional to square of the distance between them. What is that law is telling? The force of attraction or repulsion between two electric point charges is directly proportional to product of their charges and inversely proportional to square of the distance between these two charges. Or we can also say that F is directly proportional to Q1 Q2 upon R square, or F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. Okay, 1 upon 4 pi epsilon 0 here. Epsilon 0 is the permittivity of free space, Q1 Q2 these are the two static charges, R is the separation of distance between them, and that if you can solve all the values by putting pi 3.14 epsilon 8.85 into 10 raised to minus 12, then you will get the answer 9 into 10 raised to 9. Okay, Newton meter square per Coulomb square. So that is the your constant factor F. Okay, so this is the that force here which we have defined is the electrostatic force. So then what are the characteristics of that force? Okay, what are characteristics? First of all, this force is stronger than gravitational force. Okay, this force is stronger than gravitational force, than the gravitational force. By how much times? So it will be stronger means the gravitational force, electrostatic force is 10 raised to 36 times, is 10 raised to 36 times greater than gravitational force, Okay, you just remember that it is stronger than gravitational force, but how much time? That means force of electrostatic force is 10 raised to 36 times greater than the gravitational force. Okay, so that will be the your first characteristic. Second characteristics, this force is attractive as well as repulsive. This force is attractive as well as repulsive force. Okay. So what do you mean by attractive and how it will be the repulsive? Now you see here, if these two charges are the like charges, positive, positive, negative, negative, then they will repel with each other. So therefore, it will be the repulsive. But if these two charges are the unlike charges, dislike charges, one is positive, one is negative, then they will attract with each other. Okay. So now, therefore, this is attractive as well as repulsive force. Okay. It also obeys the inverse square law. It also obeys inverse square law. Okay. Then now, next characteristics. It is also long range force. It is also long range force. Okay. Means this force is also up to these two charges where you are taking into that medium. Okay. Up to that point, means up to the infinity, these two force, that means this force can be exist. Means suppose 100 is the infinity, up to 99.99 also this force can be exist. Okay. Now sir, which are, that means this force is responsible for different phenomenon at the atomic and molecular levels. Okay, so for both the levels, that is atomic as well as atomic and molecular level, this force can be exist. So where this force, that means where that examples of that any characteristics of this force. So first example is force between the two surfaces which are coming in contact. Suppose for example, if one body is moving with the another body, then this body is also have a charge, this body have also charge. So therefore, in between the two charges, there is a force of attraction or repulsion. Okay, so therefore, that means when the two bodies coming in contact with each other, that force exists is the your electrostatic force. Force of friction. Okay, force of friction also, there is interlocking is going on between the two surfaces when they are coming in contact with each other, and because of that force of friction can be existed, which always repels the motion of one body over the another body. Means what is the force? That means frictional force, the force which opposes the relative motion between the two surfaces which are coming in contact with each other. So that is also that your electrostatic force. Or tension in the string. Okay, if you can take the example of tension in the string, so that is also electrostatic force. Similarly, one side when you are defining electrostatic force, there is another side, there is the electromagnetic force also we can say here. So what is the difference between the electrostatics and electromagnetic? Only simple difference is that when the two charges are in the rest, that is the electrostatics. And when the two charges are in motion, okay, charges in motion, and due to that motion, the force exerted by the one charge over the another charge, so that force is called as the electromagnetic force, or the force acting between the electric charges in the relative motions are called as the electromagnetic force. The force depends upon, that will be the charge carried by the two bodies and the magnitude and direction of their velocities. Means what will be the magnitude of these two charges and in which direction the two charges they are moving. Okay, so this is the example of electromagnetic force. So the characteristics will be the same. This will be attractive as well as repulsive. It is also the long range force. Okay, it also obeys the inverse square law. It is stronger than the gravitational force. Okay, so these are the different, that means characteristics of that force. Okay, so the example of frictional force is produced due to the attractive force between the atoms and two bodies in the opposite side actual area of contact. Means this frictional force is also the electromagnetic force when the one body starts moving with the another body, or when the current is flowing between the, that means two conductors. Okay, so then magnetic field is produced in that two conductors. Okay, so whether this currents, means because of current flowing through the first conductor, magnetic field is produced around that conductor, and so therefore the force is exerted by this conductor on the second conductor, or the second conductor can exert the force on the first conductor. So that is also called as the your magnetic force. Okay, these are the two parallel conductor, and due to the magnetic field which is produces. Okay, current flowing through that conductors are the same, then they are attract with each other. Okay, and If where the currents flowing in opposite direction, they repel with each other. Means you see here, if these two current flowing in that parallel conductors in the same direction, they will attract with each other. But one conductor, the current flowing in this direction, one conductor, this another is, then they are repelling with each other. Here there is a repulsion, here there is a attraction is going on. Okay, so that is also the charges in motion and the force exerted by one body over the another body, one conductor over the another conductor, that will be the electromagnetic force. Next force, real force which we want to learn is the your strong nuclear force. Which force we want to learn? That is the strong nuclear force. So what is exactly strong nuclear force? Okay, so this is the third force, that is the strong nuclear force. Okay, actually sir, where this force exists? Okay, if suppose I am taking a nucleus, okay, atom, inside the atom there is a nucleus. What is there inside the nucleus? Protons and neutrons. Okay, so and outside the protons and neutrons, outside the nucleus there are the electrons are there. But this force is related with that protons and neutrons. Okay, so the what is the strong nuclear force? The force exists between any two protons or any two neutrons or any two protons or neutrons. So that is called as the strong nuclear force. Here in that strong nuclear force, electrons are not involved. So only this is inside the nucleus. Because of the force, the atom is in the stable condition. Okay, the force exists between two protons, two neutrons, or proton and neutron. So this is always in pair. So that is called as the strong nuclear force. Okay, so then what are the characteristics of this force? What are characteristics? Okay, so there are some few characteristics are like this. This is the strongest force in the universe. Strongest force. So how much it is strongest? It will be 10 raised to 30 times greater than 10 raised to 38 times greater than gravitational force. How much times? 10 raised to 38 times it is greater than gravitational force. It is the short range force. Short range force. So why it is the short range force? Because it is inside the nucleus and size of the nucleus is 10 raised to minus 14 to 10 raised to minus 15 meter. Okay, up to this size only that force can be exist. So this is the short range force. Okay, up to this distance this force can be, that means your defined strongest force, short range force. Okay, then moreover it is always attractive force. Okay, it is also attractive force. Okay, attractive force. Okay, so now these are the some characteristics. It does not obey the inverse square law. Does not obey inverse square law. Okay, this does not obey the inverse square law. So these are the basic characteristics of the strong nuclear force. Actually what happens, inside the nucleus, protons have charge, positive charge. Neutron do not have a charge. So therefore there is always in between two protons there is a force of repulsion is going on. Okay, but meanwhile there is proton and neutron, they have the masses, so therefore there is a gravitational force is also there. Gravitational force attracts to that this towards each other, so therefore that means this is the attractive. But here electrostatic force of repulsion is going on, so therefore they are repelling with each other. They are trying to that means unstabilize that nucleus. But moreover there is a third force is there in between the protons and neutrons, or that two proton or two neutrons, or proton and neutron, and that is the strong nuclear force, and that is 10 raised to 38 times. Means the gravitational electrostatic force will be 10 raised to 36 times greater, but it will be 10 raised to 38 times greater than that of the gravitational force. So therefore by 10 raised to 2 times it is greater than that of the electrostatic force. So therefore though the electrostatic force is trying to unstabilize that nucleus, but the strong nuclear force will make that nucleus stronger, and so therefore atom in the universe will be in the stable condition. Okay, so these are the, that means your characteristics of that your strong nuclear force. Okay, the force of strong interaction which binds the protons and neutrons in the nucleus of an atom. So for this is the example. Once you got that strong nuclear force, then we are coming to the point weak nuclear force, which is the another force, that is weak nuclear force. Okay, weak, that is the last force, weak nuclear force. Okay, so don't go on his name, that is not the weakest force in the universe. It will be, that will be the 10 raised to 25 times, it will be stronger than that of the gravitational force. Okay, you remember first of all that things. But it will be weaker than the strong nuclear force as well as the electrostatic force. Okay, you remember that force. So when this force will be exist, this force will be in the interaction of, okay, the weak nuclear force is much weaker than the stronger nucleus force or electromagnetic force. Okay, it is the weak nuclear force is much weaker than the strong nuclear force and the, that is electromagnetic force. It is the stronger than gravitational force. It is a very short range force of the order of size of the nucleus. Okay, the weak interaction which decays the many unstable nuclei. What happens, you know, exactly inside the nucleus there are the protons and neutrons are there, and some, when there is a decay is going on, that is alpha decay, beta decay, gamma decay, you have learned that things. When the alpha particles or beta particles, gamma particles is coming out, then along with that alpha beta decay, that will be some another particles which are also coming into that, that means your neutrino, anti-neutrino, along with that your electrons, and so therefore there is interaction is going on between that subatomic particles and that your decays. So that force is called as the weak nuclear force. Okay, so now here is, what are the characteristics of that weak nuclear force? So I have already explained to you, weak nuclear force is also, means what are the characteristics? It is characteristics. Okay, characteristics. Okay, characteristics of weak nuclear force. First, it is stronger than gravitational force. Okay, but it is much weaker than the your strong nuclear and electrostatic force Okay, so that is the next point. Then next point which we can see, that is the, that means short range force. Okay, though it is stronger, it is also short range force. Okay, this is also short range force. It does not obey the inverse square law. Okay, so these characteristics will be same. Does not obey inverse square law. Does not obey inverse square law. Okay, so these are the characteristics, and this is the best example, interaction between the, that means your particle decays of that your matter or decays of the many unstable nuclei, the force of weak interaction. Okay, so that is the example of weak nuclear force. Okay, so what are the magnitudes? Again I will say, so if this is gravitational, if this is the electrostatics, if this is the strong nuclear, okay, or weak nuclear force, weak nuclear, and this is the strong nuclear. So gravitational force is 10 raised to 0, then electrostatics will be 10 raised to 36 times greater, then this will be weak nuclear force is 10 raised to 25, and the strong nuclear force is 10 raised to 38 times, okay, than the gravitational force. So this is the your ratio of these forces. Okay, always remember the ratio of that your forces. Okay, so relative strength which we can can be say like this. Okay. So once you got that things, then we are coming to the point law of conservation of momentum. Okay, but that we can see later on. Okay, today we'll stop here. Okay, that's it.